Hello, thank you for viewing my talk on our T-Axis paper titled A3C, an image association-based computing device authentication framework for people with upper extremity impairments. My name is Krishna Venkatasubramanian, and I'm from the University of Rhode Island. This work was led by my former PhD student, Brittany. People with upper extremity impairments, or UEI, experience reduced range of motion, strength, endurance, speed, and/or accuracy associated with the movement in their shoulders, upper arms, forearms, hands, and/or fingers. UEI can be caused by a variety of different conditions, including cerebral palsy, amputation, and arthritis. Over 20 million people in the US alone have conditions which lead to UEI. Existing authentication processes for computing devices often make ability assumptions that require the user to perform complex actions with their hands, arms, or fingers. This can cause barriers for people with UEI. Our goal in this work is to make computing device authentication more accessible for people with UEI. So far, work to explore device authentication for people with UEI has been limited. None of these methods have been widely adopted. In this paper, we present a novel authentication framework called A3C. A3C is a recognition-based graphical authentication framework specifically designed for people with UEI to authenticate to their computing devices. During setup, A3C requires users to 1. Provide a set of primary images recognizable to them, and 2. Associate each primary image with a secondary image. The association between the primary and secondary image is entirely up to the user and never documented. During credential verification, A3C asks the user to recognize a subset of the primary images displayed among a set of decoy images. This is followed by randomly picking a user-selected primary image and associating a secondary image to it from among a set of decoy secondary images. The A3C framework, in theory, can use any kind of image for its primary and secondary images. We instantiated A3C by using faces of people that the user knows for primary images and animal images for secondary images, and called this instantiation A3C-FA. Further, we also created two versions of A3C-FA, one that uses distorted primary images during credential verification and another that didn't use distortion of any kind. In order to evaluate A3C-FA, we performed three main evaluations. In the interest of time, we will describe only two of them here. The first evaluation is determining the efficacy of A3C-FA against shoulder surfing attacks. A shoulder surfing attack is when an opportunistic adversary is able to watch a user log in to a computing device and use the information to log in themselves at a later time. For the shoulder surfing evaluation, we recruited 321 participants on Amazon Mechanical Turk. We used pass faces as our control authentication approach, which is similar to the first stage of A3C-FA's authentication, except it requires the users to remember a set of random faces. The idea behind evaluating the shoulder surfing attack was to video record ourselves logging in successfully using A3C-FA or pass faces. Subsequently, we showed this video to a would-be attacker and asked them to log in using a new instance of A3C-FA or pass faces. Overall, the attacker is asked to perform this attack 5 times, each time with a new instance of A3C-FA or pass faces. The study concluded after the 5 attempts, or if the attacker succeeded in logging in. We found the two versions of A3C-FA, namely A3C-FA distorted and A3C-FA undistorted, to be much more secure than pass faces. Only about 1/3 of the attackers were successful after 5 attempts with the two versions of A3C-FA compared to pass faces. For more details on the results, please see our paper. Next, we evaluated the usability of A3C-FA. We recruited 14 participants for the usability study, with 7 participants being shown A3C-FA undistorted and 7 participants being shown A3C-FA distorted. Additionally, for the usability study, we used celebrity photos as a stand-in order to protect the participant privacy and avoid storing their personal photos over the length of the study. There were 3 sessions in the usability study, each of which involved the participant logging in using A3C-FA and then participating in a short interview. The second session took place 1 week after the first session, and the third session took place a month after the first session. Overall, the participants felt that A3C-FA had security advantages over other user-friendly credential entry mechanisms such as voice-based password entry. Further, Participants also found that A3C FA was more convenient than other methods, especially those that required typing. For more details on these and other results, please see our paper. In conclusion, the A3C framework shows promise as an accessible and secure alternative to existing solutions against opportunistic attackers for people with UEI. Thank you for listening to this talk. You can get in touch with me by emailing me at krish@uri.edu. Thank you.